Right now, somewhere in the world, an AI agent just called a bank. It spoke in a real human voice. It answered the security questions correctly. It passed the identity check, and it walked away with access to an account that didn't belong to it. No human was involved in the attack. No human caught it in time. And the technology to do this, it costs almost nothing to get. The arms race between AI attackers and AI defenders is happening at a scale most people don't understand. And hidden inside this battle are three technologies that are rewriting the rules of digital trust. Rules that affect every person who has a bank account, a phone number, a digital identity, or a voice. Stay with this, because what we're about to cover goes much deeper than just cybersecurity. It's about who gets to be trusted in a world where machines can perfectly impersonate humans, and how three very different innovations are fighting back. Before we go any further, if this is the kind of content that makes you think differently about the world around you, drop a like right now. Leave a comment below with what you think. Is AI making us safer or more vulnerable? And if you haven't subscribed yet, hit that button so you don't miss what's coming. Let's start with the problem, because without understanding how bad it actually is, the solutions don't make sense. Fraud, not the old-fashioned kind where someone steals your wallet or guesses a password. Something categorically different, something most people haven't fully processed yet. In 2025, AI-driven fraud surged by 1,210%, not 12%, not 120%, 1,210. Traditional fraud, the kind humans do manually, grew by 195% in the same period. That's a large number too, but it means AI-driven fraud is growing more than 6 times faster than human-driven fraud, and it's still accelerating. Here's what that looks like in practice. A fraud ring deploys an AI agent against a financial institution's phone system at 2 in the morning. The agent navigates the automated menu. It answers knowledge-based security questions using stolen personal information. It reaches a live agent. When the live agent pushes back with a question that wasn't in the script, the AI adapts, calm, polite, persistent. The account gets accessed, the transaction goes through, and at no point was a human attacker ever on the line. Contact centers are currently experiencing a fraudulent call attempt every 46 seconds. 1 in every 599 calls now involves some form of fraud. Deepfake audio, voices synthesized to sound exactly like a specific person, surged 1,300% in a single year, and generative AI fraud is projected to reach $40 billion in losses in the United States alone by 2027. The threat is not theoretical. The threat is already industrialized. So why is the voice channel specifically under such extreme pressure? For decades, the voice was considered one of the most trustworthy authentication signals we had. You recognize people's voices. Your voice carries patterns that are uniquely yours: the rhythm of your breath, the resonance of your throat, the micropauses between words. These things aren't easy to fake perfectly. But that assumption collapsed. Modern voice synthesis can now replicate a person's voice with just a few seconds of source audio. Social media, voicemails, customer service recordings, these are all potential sources. And once a voice is cloned, it can say anything, respond to anything, sound calm under pressure in a way that a nervous human fraudster often can't. The security question isn't just, is this voice familiar anymore? The question is there a real, living human being producing this voice right now? That question, liveness, is at the heart of the first technology we need to talk about. The platform that has emerged as the defining force in voice liveness detection was built on a simple but radical insight. The real signal in a voice isn't just what is said, it's the physical artifacts of a human body producing sound in real time. A human voice contains hundreds of microsignals that are almost impossible to fake perfectly. Respiratory patterns, subtle harmonic shifts, the way air moves through a physical throat, frequency behavior that changes moment to moment because a living body is always in motion. These are the signals that synthetic voices, no matter how good, tend to miss in tiny but detectable ways. The system that performs this analysis operates across more than 1,300 signals simultaneously. It produces a result in approximately 2 seconds. Not a yes or no, a probabilistic risk score, because trust is a spectrum, not a switch, and it's already running on the infrastructure of 7 of the top 10 U.S. banks. Trained over 1.5 billion real-world interactions every year, protected by more than 300 patents, expanded in early 2026 into healthcare, a sector where synthetic voice attacks targeting patient records and insurance benefits have become one of the fastest-growing fraud categories. The results are striking. Deployments have achieved over 90% reductions in voice fraud. In one healthcare case, a coordinated attack targeting 1,200 patient accounts was stopped before a single fraudulent transaction completed, preventing an estimated $18 million in losses. But here's the part of this story that most people miss when they focus only on voice detection. A voice liveness score tells you whether the signal is real. It doesn't tell you whether the person behind the signal is who they claim to be. These are two completely different problems, and solving only one of them leaves a critical gap. This is where the second technology enters, and it addresses something that has been a quiet catastrophe waiting to happen inside almost every large institution on the planet. Think about how biometric data is currently stored. When a financial institution or a healthcare provider or a government agency collects your fingerprint, your face scan, or your voice pattern, where does it go? In most architectures, it goes to a centralized database, one location, one system, one potential target. The security community has a specific name for this, a honeypot. A honeypot is a database so valuable that breaking into it once means you've won everything. If you compromise a centralized biometric database, you don't just get one person's identity, you get every identity that institution has ever enrolled. And here's the catastrophic part. Unlike a password, a biometric cannot be changed. You can issue someone a new password, you cannot issue them a new fingerprint, you cannot issue them a new face, you cannot issue them a new voice. One breach of a centralized biometric database is a permanent, irreversible identity compromise for every single person in it. The solution to this problem had been theorized in security circles for years, but putting it into practice at enterprise scale, that's what changed. The approach works like this. A biometric record, a face, a voice pattern, a fingerprint, is never stored whole anywhere. Instead, it's mathematically fragmented, cut into encrypted shards. Each shard individually is meaningless. It cannot be reconstructed to the original. These shards are then distributed across multiple separate nodes in a decentralized cloud infrastructure. No single node holds enough information to reconstruct a usable identity. If one node is breached, the attacker gets encrypted noise, not data, not an identity, noise. When someone needs to be verified, the system doesn't reassemble the biometric. It generates new encrypted fragments from the person's current biometric input and compares them cryptographically against the stored shards, without the original ever being reconstructed anywhere. The verification happens through a form of zero-knowledge proof, where the system confirms a match without seeing the thing it's matching against. The architecture that pioneered this at production scale calls this framework the Circle of Identity, and in May 2025, it became the first platform to deploy these decentralized biometric principles specifically for agentic AI workflows, meaning not just protecting human authentication, but securing the identity of AI agents acting on behalf of humans.
Let's pause here, because this point deserves its own moment. Agentic AI doesn't just create new attack vectors for fraudsters, it creates a new identity problem from the inside. When an AI agent makes a purchase, authorizes a transaction, changes account details, or interacts with another system on your behalf, that agent needs to be trusted. Not just trusted to work correctly, trusted to be you, trusted to carry your authorization, your credentials, your permission. Previous generations of AI operated under generic API keys. There was no binding between the AI's actions and the verified identity of the human it was supposed to represent. An agent could be compromised, hijacked, or simply misused, and there was no cryptographic record tying its actions to a verified human being. Identity-bound agents change this entirely. The AI agent's authorization is cryptographically tied to the verified biometric identity of the human user without storing that biometric in any single recoverable location. The agent carries proof of identity without carrying the identity itself. This isn't just a security upgrade, it's a governance architecture for the age of autonomous AI. Because if AI agents are going to act in the world, handling payments, accessing systems, making decisions, the question of who is accountable cannot have a vague answer. Now let's bring the three layers together, because this is where the real picture emerges. Layer 1. Voice liveness detection running on every incoming call, analyzing 1,300 signals in 2 seconds, producing a risk score that identifies whether a human body is producing this audio right now or whether a machine is generating it. Layer 2, decentralized biometric identity verification, confirming that the person whose voice matches the liveness check is who they claim to be, without storing a complete biometric record anywhere that can be stolen. Layer 3, Agentic AI as the orchestration system, receiving both signals simultaneously, combining them with session metadata, behavioral patterns, device fingerprints, and transaction context, and making a real-time decision without waiting for a human analyst to review a ticket. The output isn't binary. The system doesn't just block or allow, it routes intelligently. A slightly elevated liveness score on a verified, identity-bound caller might trigger a passive step-up, a push notification to the user's registered device asking for a quiet confirmation. A high-risk liveness score on an unverified session gets blocked immediately. Normal calls pass through without any friction. Legitimate customers never know a verification check happened. Research from deployed agentic security systems shows this autonomous threat response cuts incident response time by more than 50% compared to rule-based systems. And that's the critical point. Fraud attacks unfold in milliseconds. A system that waits for a human to review a ticket will always lose. The speed advantage goes to whichever side can act faster, and that is now determined by automation, not headcount. Let's talk about numbers, because numbers tell a story that abstract descriptions can't. One bank that adopted the agentic fraud investigation layer reported a 50% improvement in fraud case disposition accuracy. Across all early deployments, analyst efficiency increased by up to 70% on average. The estimated value generated across operational savings and fraud loss prevention? An average of $1 million per organization annually. And that's a conservative figure given the scale of fraud exposure these institutions face. In the retail banking sector, synthetic voice attacks rose 149% in 2024. The primary targets? High-value transaction authorizations, account details changes, and SIM swap requests. Healthcare contact centers now report that more than half of fraud attempts involve AI-generated elements. The EU AI Act moves into full enforcement in August 2026, requiring organizations using automated systems in interactions with individuals to meet new transparency and risk management standards. The organizations building this architecture now are doing so before the regulatory pressure lands. The ones who wait will be building it under deadline. Now here's something that almost no coverage of this topic mentions, and it matters. The compliance benefit of decentralized biometric architecture isn't just a security story, it's a legal story. Under GDPR Article 9, biometric data used for identification is classified as a special category of personal data requiring explicit protection and declaration. Under CCPA, similar obligations apply. If you store biometrics in a central database, that database becomes a compliance liability, something that must be declared, protected, reported on, and defended in the event of a breach. Decentralized biometric sharding eliminates the central store entirely. There is no single biometric database to declare. There is no honeypot to report.
Legal teams at financial institutions have flagged this as a material risk reduction, not a niche security feature, but a structural change in how data liability is distributed. The architecture isn't just quantum resistant, it's already resistant to the regulatory pressure that's arriving in the next 12 months. And now we arrive at the question that this whole story is pointing towards, the question that will define how trustworthy the agentic AI future actually is. We are building a world where AI agents do things on our behalf. They call, they authorize transactions, they access records, they initiate processes in systems that affect real people's lives and real money. In that world, the word trust cannot be vague. It cannot be assumed. It cannot rest on a password that can be stolen, a security question that can be answered by someone who looked up your personal information online, or a voice that can be cloned from 20 seconds of social media audio. Trust in the agentic AI era has to be verifiable, it has to be real-time, it has to be unfalsifiable, and it has to be decentralized enough that a single breach doesn't bring the whole structure down. The architecture we've talked about today, layered voice liveness, decentralized biometric identity, and agentic AI orchestration, isn't a product, it's a framework. It's a set of principles about what security has to look like when the attackers are also AI. Fraudsters aren't waiting. The data is unambiguous. 1,200% growth in AI-driven fraud in a single year isn't a trend line you watch, it's a trajectory you respond to, now with the right tools, the right architecture, and a clear understanding of what's at stake. The world we are entering isn't one where AI is simply more convenient, it's one where AI is the primary actor in millions of daily transactions, interactions, and decisions. The question of whether that world is safe, whether the AI acting on your behalf can be trusted, whether the AI contacting your institution can be verified, whether the identity infrastructure underneath it all can survive a breach, that question is being answered right now. Not in press releases, not in conference presentations, in architecture decisions being made today, in deployments happening today, in fraud attacks being stopped or not stopped today. The systems built to answer that question are not theoretical. They are running, they are learning, and in the arms race between autonomous AI attackers and autonomous AI defenders, the side with the better architecture wins. The side with better architecture right now is not the one you'd expect to fall behind. Stay curious, because this is only the first chapter of a story that has no clear ending yet, and every person with a digital identity has a stake in how it turns out.